Welcome to Module 4, Transparency, Explainability, and Accountability in AI Systems. In this module, we move from asking whether an artificial intelligence system can produce useful results to asking whether those results can be examined, understood, and responsibly governed. That shift matters because AI systems increasingly appear inside decisions about work, education, healthcare, finance, and organizational strategy. When systems influence decisions that affect people, accuracy by itself is not enough. They also need to be open enough for people to evaluate how they operate. Transparency gives us a way to begin that evaluation. At a basic level, transparency refers to the degree to which people can see into the design, data, assumptions, limits, and behavior of an AI system. This does not mean every stakeholder needs to read source code or understand every parameter inside a model. It means that the people affected by a system and the people responsible for deploying it need meaningful visibility into how the system functions. Without that visibility, an AI output can appear authoritative while remaining difficult to question, creating serious problems for trust, oversight, and responsible decision making. Explainability takes us deeper into the question of understanding. Many modern machine learning systems, especially complex models, can identify patterns that are difficult for humans to trace directly. They may produce recommendations, classifications, scores, or predictions that seem useful, yet the reasoning path behind those outputs may not be obvious. This is the familiar black box problem, but in a graduate level conversation, we should treat that phrase carefully. The concern is not simply that a model is complicated. The concern is that complexity can make it difficult to know whether the model is relying on appropriate signals and whether a particular decision can be justified in context. Accountability then asks what happens after an AI system produces an outcome. If a system recommends denying a loan, prioritizing one patient over another, screening out a job applicant, or flagging a person for further review, responsibility cannot be left floating in the technology itself. Organizations have to determine who is answerable for the design choices, deployment choices, monitoring practices, and human decisions connected to that system. Accountability is therefore a structure for assigning responsibility, where automated tools shape consequential outcomes. A responsible organization cannot say that the model made the decision and treat that as the end of the matter. As we work through this module, we will connect these three ideas rather than treating them as separate topics. Transparency helps make AI systems visible enough to inspect. Explainability helps stakeholders understand how inputs, model behavior, and outputs relate to one another. Accountability helps ensure that someone has the authority and responsibility to respond when the system behaves poorly, produces harm, or requires correction. Together, these concepts form a practical foundation for responsible AI because they bring technical systems back into human governance. One important theme will be that transparency and explainability are not automatically the same thing. A system might be transparent because its documentation, purpose, training data sources, and deployment contexts are clearly described while still being hard to explain at the level of individual predictions. Conversely, a model might offer an explanation for a particular output while the broader organizational process remains opaque. Responsible AI requires attention to both levels. We need to understand how a model works, but we also need to understand who selected it, why it was deployed, what safeguards surround it, and how its outcomes are reviewed over time. The practical work of this module is therefore about oversight, not just interpretation. Documentation, auditing, internal review boards, and accountability frameworks all give organizations ways to examine systems before, during, and after deployment. None of these practices solves the entire problem alone. Together, they help move responsible AI from a general aspiration into an operational practice. By the end of this module, the goal is to develop a more mature way of thinking about AI oversight. We are not simply asking whether a system works. We are asking whether its operation can be examined, whether its outputs can be explained, and whether responsibility for its effects has been assigned. These questions are important in organizations where AI systems may be developed by one team, purchased from a vendor, deployed by another department, and experienced by people who had no role in selecting the technology. In that environment, responsible AI depends on structures of review, documentation, and accountability. That is the lens we will use as we begin Module 4. In this slide, we begin with algorithmic transparency, one of the main ideas in responsible AI. Transparency means that an AI system should not operate as a mysterious authority whose outputs must simply be accepted. Instead, people who design, deploy, manage, regulate, and experience the system need meaningful visibility into how it operates. That visibility may include information about the data being used, the purpose of the model, the assumptions behind its design, and the way outputs are generated. An AI system may be fast and accurate, but if no one can examine how it reached the result, the organization has limited grounds for responsible oversight. This matters because artificial intelligence increasingly influences decisions affecting individuals and organizations. These systems may influence who receives an opportunity, which application moves forward, what information is prioritized, or how scarce resources are allocated. In that context, transparency is not a purely technical concern. It becomes a question of whether affected people and responsible institutions can understand the role the system played in a decision that may matter in practical, professional, or personal terms. Algorithmic transparency focuses on understanding how the system operates. That does not mean every stakeholder needs to read source code or master the mathematics behind a model. It means that the system should be open enough for appropriate stakeholders to ask informed questions about its design and behavior. A technical team may need detailed performance information. A manager may need a clear account of risks and limitations. And an affected individual may need a plain language explanation of why a result occurred. Transparency therefore has to be matched to context, audience, and decision impact. One reason transparency is so important is that AI outputs can appear objective even when they are shaped by human choices. The selection of training data, the definition of the target variable, the choice of performance metrics, and the decision about where the system will be used all influence the final outcome. If those choices remain hidden, stakeholders may treat the output as more neutral than it really is. Transparency helps reveal that an AI system is not independent of its design environment. It is a built system shaped by assumptions, constraints, priorities, and trade-offs. Stakeholders need visibility into why a system produced a particular outcome, because decisions often require explanation, review, and sometimes correction. If a model contributes to an unfavorable recommendation, the organization should be able to examine whether the relevant inputs were appropriate, whether the model behaved as expected, and whether the output was used responsibly. Without that visibility, people may struggle to challenge an outcome or even understand what happened. This is especially important when AI supports decisions that affect access, evaluation, eligibility, or risk. A system that cannot be examined can quickly become a system that cannot be governed. Greater transparency also supports responsible AI development by making system behavior easier to test and improve. During development, Transparent documentation helps teams record what data were used, what limitations were identified, what alternatives were considered, and what risks were accepted. During deployment, transparency supports monitoring because organizations can compare expected behavior with actual outcomes. If the system begins to perform differently across groups, contexts, or time periods, transparency gives the organization a foundation for investigation. In this way, transparency is not only about explaining past decisions. Without transparency, individuals, regulators, and organizations may struggle to evaluate AI outcomes. A regulator cannot assess whether a system is appropriate if the relevant design and deployment information is unavailable. An organization cannot assign responsibility clearly if no one can trace how the system was built, tested, approved, and used. Individuals affected by the system may feel that decisions are being made behind a closed door, even when a human remains in the process. This lack of visibility weakens trust because people are being asked to accept an outcome without a meaningful basis for understanding it. So, algorithmic transparency should be understood as a condition for responsible decision making. It helps connect technical systems to human judgment, organizational oversight, and ethical evaluation. It does not require every AI model to be simple, and it does not eliminate every uncertainty. What it does require is that important features of the system can be examined by the people who need to evaluate them. In responsible AI, transparency matters because it lets stakeholders ask informed questions, identify limitations, review outcomes, and hold decision processes to a higher standard. On this slide, we turn from transparency to one of the hardest practical questions in responsible AI: explainability in complex models. The slide points us toward the black box problem, which is common in modern machine learning systems. A black box system is not necessarily a system that performs badly. Many of the models that raise explainability concerns are valuable because they detect subtle patterns, process large amounts of information, and generate accurate predictions or recommendations. The challenge is that the internal path from input to output may be difficult for humans to interpret. This creates a tension that appears throughout applied artificial intelligence. On one side, organizations often want models that perform well, especially when they are working with complex data such as text, images, behavioral patterns, medical signals, or financial histories. On the other side, the more complex a model becomes, the harder it may be to explain how a specific result was produced. A simple decision tree might allow someone to trace a prediction through visible rules. A neural network, by contrast, may rely on thousands or millions of learned relationships that do not translate neatly into a readable explanation. Black box systems can be especially difficult because usefulness may conceal uncertainty. A prediction can look precise, a recommendation can look confident, and a classification can look authoritative, even when the human user does not understand what the model actually relied on. This matters because an AI system may learn patterns that are statistically powerful, but socially or ethically inappropriate. For example, a model might use variables that appear neutral on the surface, but function as proxies for sensitive characteristics, historical disadvantages, or institutional patterns. If the model is not explainable, those relationships may remain hidden until harm has already occurred. Limited explainability also becomes a problem when stakeholders ask why a specific outcome occurred. In ordinary organizational settings, people expect reasons. A manager may need to explain why one applicant was ranked higher than another. A healthcare professional may need to understand why a risk score changed. A financial institution may need to justify why an application was flagged or denied. When the AI component cannot be explained, the organization may struggle to connect the automated output to a defensible human decision. Explainability is not only a technical feature, it's also a communication problem and a governance problem. A model explanation has to be meaningful to the audience receiving it. A data scientist may need information about feature influence, model behavior, and error patterns. A compliance officer may need documentation that supports review and accountability. A person affected by a decision may need an explanation that is understandable without specialized technical training. If an explanation is mathematically detailed but unusable for the relevant audience, it may not serve the purpose responsible AI requires. The challenge becomes more serious when AI affects employment, healthcare, financial access, or legal decisions, because those areas involve significant consequences for people's lives. In low-stakes settings, a confusing recommendation may be inconvenient. In high-stakes settings, a confusing recommendation can affect opportunity, safety, liberty, or access to essential services. This is why black box models create pressure for stronger oversight. The more consequential the decision, the stronger the need to understand what the system predicted, how it should be interpreted, and when it should be reviewed or corrected. We should also avoid assuming that explainability is a simple switch that can be turned on. Some models are easier to interpret than others, but every explanation involves choices about what to reveal and how to simplify complexity. A complete technical account may be too dense to be useful, while a simplified explanation may leave out important details. Responsible AI requires careful judgment about the level of explanation needed for a system, audience, and decision context. The goal is not to make every model perfectly transparent, but to make it understandable enough for responsible use. So, the lesson of this slide is that explainability challenges grow as AI systems become more complex and more consequential. A model may produce an accurate or useful output while still being difficult to interpret. That difficulty matters because people and organizations need reasons, not just results. When stakeholders cannot understand why an outcome occurred, it becomes harder to evaluate fairness, identify errors, challenge inappropriate outputs, and assign responsibility. In responsible AI, explainability is part of what allows complex systems to remain connected to human judgment, ethical review, and accountable decision making. For this slide, we look at methods used to increase interpretability and transparency in machine learning systems. The move is from recognizing the black box problem to asking what organizations can do about it. Explainable AI, often called XAI, is one major response because it tries to make machine learning systems more understandable without abandoning the power of complex models. In practice, XAI is not one single technique. It is a family of approaches that help people see how a model uses information, how inputs influence outputs, and where the system may require closer review. A central purpose of XAI is to help users understand the relationship between inputs and outputs. When a model produces a prediction, it is not enough to know only the final label, score, or recommendation. Stakeholders often need to know which factors contributed most to the result and whether those factors make sense for the task. For example, if an AI system estimates risk, users may need to know whether the estimate was influenced by relevant evidence or by a pattern that is misleading or inappropriate. Interpretability methods are valuable because they reveal those connections in a way that supports human judgment. Some interpretability methods focus on global understanding, meaning they try to explain the model's overall behavior. These methods help answer questions such as which variables generally matter most, how the model behaves across different ranges of input values, and whether the system relies on reasonable patterns. Other methods focus on local explanations, which means they try to explain one particular prediction or recommendation. Local explanations are especially useful when someone asks why this specific outcome occurred in this specific case. Both levels matter because responsible AI requires understanding both the broader system and the individual decisions it helps shape. Interpretability can also involve choosing models that are more understandable from the beginning. In some settings, a simpler model may be preferable because its decision process is easier to examine and justify. A transparent model may not always produce the highest possible accuracy, but it may offer a better balance between performance, oversight, and trust. In other settings, organizations may decide that a more complex model is appropriate, but then they need stronger explanation tools, monitoring practices, and review procedures. The choice is about matching model design to the risks and responsibilities of the context. Documentation is another method for increasing transparency, and it is often underestimated. Documentation records what the system is intended to do, what data were used, what design choices were made, what limitations were identified, and how the model should and should not be used. This documentation gives reviewers a way to understand the system beyond the output itself. It also helps future teams avoid treating the model as an isolated technical artifact with no history. When documentation is weak, organizations may lose track of why a system was built, what assumptions guided it, and what conditions were considered acceptable for deployment. Auditing adds another layer of responsible review. An audit examines the system, its behavior, and its outcomes to determine whether it is performing appropriately. This may include checking accuracy, error rates, subgroup performance, data quality, fairness concerns, and alignment with organizational policies. Auditing is especially important after deployment because systems can behave differently when they encounter new data, changing populations, or different operational conditions. A model that performed acceptably during development may still need ongoing review once it is used in real decision-making environments. Together, XAI techniques, interpretability methods, documentation practices, and auditing processes support transparency from different angles. XAI helps explain how inputs influence outputs. Interpretability methods clarify how predictions are generated. Documentation preserves the reasoning, assumptions, and design decisions behind the system. Auditing evaluates whether the system's actual behavior remains acceptable over time. None of these practices eliminates all uncertainty, but each one makes the system easier to examine and govern. The broader lesson is that transparency in machine learning is not achieved by a single explanation attached to a prediction. It is built through practices that make the model, its context, and its consequences more visible. Responsible organizations need to ask whether users understand the output, whether decision makers know the limits of the system, whether reviewers can examine design choices, and whether outcomes can be monitored after deployment. When these methods are used together, interpretability becomes part of the governance structure that allows AI systems to be used responsibly. Now we turn to accountability in AI-driven decision making. And this is where the discussion becomes important for organizations. Transparency helps us see how a system operates, and explainability helps us understand why a result may have occurred. But accountability asks a different question. Who is responsible when an AI system influences an outcome? AI systems are designed, trained, selected, approved, deployed, monitored, and interpreted by people and institutions. So accountability is about creating a clear responsibility structure around the entire decision process. This becomes complicated because automated systems often contribute to decisions without being the only actor involved. A model might generate a score, rank a list, flag a case, recommend an action, or classify a person into a category. A human may review that output, but the review may be brief, constrained by workload, or influenced by the apparent authority of the technology. In that setting, responsibility is not always obvious. It's the responsibility with the developer who built the model, the vendor who sold it, the manager who approved it, the employee who used it, or the organization that placed the system into a consequential workflow. Responsible AI requires organizations to answer that question before harm occurs, not after. If an AI system affects employment, healthcare, finance, education, or legal decisions, the organization needs to know who has authority to approve the system, who monitors performance, who responds to complaints, and who can suspend or modify its use. Accountability is not merely about blame after failure. It's about assigning duties in advance so that oversight is continuous and decision-making remains under human and institutional control. Documentation is one mechanism for supporting accountability because it creates a record of decisions. It can show why a system was adopted, what data were used, what risks were identified, what limitations were accepted, and what safeguards were put in place. Without documentation, accountability becomes vague because people may not be able to reconstruct how the system entered the organization or how its use changed over time. A well-documented AI system gives reviewers a trail of reasoning and responsibility. Auditing also plays a major role because accountability requires evidence. It is not enough for an organization to claim that its AI system is fair, accurate, or appropriate. The system has to be examined through performance testing, outcome analysis, subgroup evaluation, and review of how it behaves in deployment. Audits help identify whether the system is producing unexpected errors, unequal impacts, or outputs that do not align with organizational values and legal obligations. In this sense, auditing connects responsibility to measurable review. Internal review boards can strengthen accountability by creating a formal space where AI uses are evaluated before and during deployment. These boards may include technical experts, compliance professionals, managers, ethicists, domain experts, and sometimes representatives who understand the affected population. Their purpose is to ensure that consequential AI systems receive serious review before they are placed into practice. A review board can ask whether the system is appropriate for the use case and whether escalation procedures exist when something goes wrong. Accountability frameworks bring these pieces together by defining roles, approval processes, reporting requirements, and response mechanisms. A framework might specify who owns the model, who owns the data, who owns the business decision, and who has responsibility for monitoring outcomes. This matters because AI systems often cross organizational boundaries. A technical team may build the system, a vendor may maintain part of it, and a business unit may use it. Clear mechanisms reduce the risk that responsibility disappears between teams. The deeper point is that AI systems do not make accountability unnecessary. They make it more necessary. Automation can create distance between the people who design a system and the people affected by its outputs. It can also create uncertainty about whether a decision came from a model, a human, a policy, or some combination of all three. Clear mechanisms help organizations keep that chain visible and ensure that AI-driven decision-making remains subject to review, correction, and responsible governance. So when we assess accountability in AI, we should look for more than a statement that humans are still in charge. We should ask who specifically is responsible, what authority they have, what evidence they review, what procedures they follow, And what happens when the system produces an unacceptable outcome? Responsible AI depends on this clarity because consequences do not belong to the machine. They belong to the organizations and people who choose to use the machine in decision making. In this final slide, we compare several organizational strategies for implementing responsible AI oversight. The focus is no longer only on what an AI model does internally, but on how an organization builds a structure around the system so that its use can be reviewed, questioned, and corrected. Responsible AI oversight requires more than good intentions from individual employees. It requires repeatable practices that clarify who approved it, how the system is monitored, and what happens when outcomes raise concerns. Documentation, auditing, internal review boards, and accountability frameworks each contribute to that larger governance structure. Documentation practices are one of the most basic forms of oversight because they create records that others can review. A well-documented AI system should make it possible to understand the purpose of the system, the data used to build or configure it, the assumptions behind its design, the known limitations, and the conditions under which it should be used. This record matters because organizations change over time. People move roles, vendors update products, data sets shift, and business needs evolve. Without documentation, the organization may lose the memory of why a system was adopted and what risks were considered before deployment. Auditing processes give organizations a more active way to examine system, behavior, and outcomes. An audit asks whether the system is performing as expected, whether its results remain reliable, and whether its outcomes create patterns that require attention. This can involve reviewing accuracy, error rates, subgroup differences, data quality, user behavior, and the match between these systems' intended use and its actual use. Auditing is especially important after deployment because real-world conditions rarely remain static. A model that seems appropriate during testing may behave differently when it encounters new populations, new inputs, or changing organizational practices. Internal review boards add another layer by creating a formal governance mechanism for evaluating AI use. Instead of allowing teams to deploy consequential systems based only on local enthusiasm or technical performance, a review board can bring multiple perspectives into the decision. Technical experts may examine model design and limitations. Compliance professionals may consider legal and policy obligations. Managers may evaluate operational fit. And domain experts may assess whether the system makes sense in practice. This kind of review is useful because AI oversight often requires judgment across several areas at once. Accountability frameworks help define responsibility for decisions influenced by AI systems. They answer questions that can otherwise become unclear. Who owns the model? Who owns the data? Who approves deployment? Who monitors outcomes? Who responds to complaints? And who has authority to stop or revise the system? These questions matter because AI systems often sit between departments, vendors, managers, technical staff, and end users. If responsibility is not assigned clearly, everyone may assume that someone else is handling the problem. A framework reduces that ambiguity by connecting oversight duties to specific people, roles, and procedures. When we compare these strategies, it is important to see that they are not interchangeable. Documentation preserves the history and rationale of the system. Auditing tests whether the system's behavior and outcomes remain acceptable. Internal review boards create a structured decision-making process before and during deployment. Accountability frameworks assign responsibility so that oversight is not left to informal assumptions. Each strategy addresses a different weakness that can appear when organizations rely on AI without sufficient governance. Together, these strategies help organizations implement responsible AI oversight during deployment. Deployment is the point at which a model leads development, and begins interacting with real users, data, decisions, and consequences. That is why oversight cannot end once a model is launched. Organizations need to monitor whether the system continues to fit its purpose, whether outcomes remain appropriate, and whether human decision makers are using the tool responsibly. Responsible deployment means treating AI as an ongoing organizational responsibility, not as a finished technical product. The broader lesson of this slide is that responsible AI oversight is a system of practices. Documentation gives the organization a record. Auditing gives it evidence. Review boards give it structured judgment. Accountability frameworks give it responsibility. When these elements work together, AI governance becomes more than a policy statement. It becomes a practical process for examining systems, responding to risks, and ensuring that decisions influenced by AI remain connected to human review and institutional responsibility.